Hey there, class. Mr. Pusky here. This is part 2 of the 3.1 through 3.3 quiz review. So we're going to go through this together. We're going to finish this off. We got a few more examples to do. I just didn't want to record it all in one video because it's kind of long. So, all right, it says graph the system of linear inequalities. So let's get into it. Y is greater than or equal to negative 1/2 x plus 2. All right, well, that's going to be, it's greater than or equal to. So that is going to be, it's equal to, it's going to be a solid line, and it's going to be shaded above because it's greater than. So let's go ahead and do that. So we're going to graph the line y equals negative 1/2 x plus 2. So we're going to go up 2 with a point. Negative 1/2 means we go down 1, right 2, down 1, right 2. Keep going. And we can go up 1, left 2 as well. And we're doing a solid line. Not perfect, but we'll stick with it. And the other equation we're going to do is x is greater than negative 2, so that a solid or a dashed line, if it's not equal to, it's dashed. And shaded to the left or to the right if it's x equals, if it's a vertical line, shaded to the right. So we're going to do a dashed line through the vertical line x equals negative 2. So we're going to go like this. Oh, sorry, I forgot to draw some arrows for the last equation. So we're going to draw some arrows going above like this for the green one. And then for the blue one, or indigo one, we're shaded to the right. So we're going to go to the right. And I'm just going to stick up there because it's got to be above and to the right. So then we're going to see where these cross, which is going to be up. Yeah, it's not a good color. We'll stick with red or pink. So that is the solution where they cross, where those overlap. Okay? All right. Number 11, this one's going to be a fun one. All right, so we got x is less than or equal to 5, so that's going to be a vertical solid line through 5. So 1, 2, 3, 4, 5. Do you want to make the straight line or no? Why is it not wanting to work? One, two, three, four, 5. So a solid line, we're shading to the left. And then we're doing x is greater than negative 1. So we're going to do a vertical line through negative 1. It's going to be a dashed line. It's going to be shaded to the right. And then we have y is less than 2x plus 4, so we're going to go up 4, 1, 2, 3, 4. We're going to go, our slope is up 2 over 1, so up 2 over 1, up 2 over 1, down 2 left 1. That's a dashed line. And it's shaded below, so we're going to be below, or it's going to go in this area because this is below over here. Okay, all right, and then we have the last one we got to solve for, so let's go ahead and do that. So we need to get y by itself, so we're going to subtract 3x. 3y equals negative 3x plus 6. Divide by 3. So our answer is going to be y is not equal to, sorry, I gave that up. And we also divided by a negative, oh no, we divided by a positive. So it's going to be y is less than or equal to negative x plus 2. So negative x plus 2, we're going to go up 2, put a point. We're going to go down 1, right 1. Up 1, left 1. Let me double check my answer here. Oh, you know what? I goofed this up. No, I didn't. That's weird. Huh, the key I have is a wrong problem, so we're good. We're doing the right thing. And this one is shaded below. It's a solid line. So for this one, it's going to be below the orange line, between the indigo and green lines, and it's going to be below the purple line. So we're actually going to be right down here. And that shaded section is the solution for this one. All right, so that's how we draw the arrows, because we're not sure exactly where things are going to go here. All right, let's see here. Determine if the ordered pair is the solution of the given system. Well, let's do it. So we have 5, 6. We're checking negative 2x plus 4y equals negative 14. 3x plus y equals 21. And we are checking whether this is a solution. So we've got our x and our y. We're going to plug it in for both of these, make sure it's true or not. Negative 2 times 5 plus 4 times 6 equals negative 14. That's going to be negative 10 plus 24 equals negative 14. That is going to be 14 equals negative 14. So we can automatically stop there. That's not true. So this is going to be not a solution. Not a solution. And then we have number 13. Same thing, 2, 7 we're checking for x and y. We have x is greater than or equal to negative 1 and y is greater than 2x plus 2. So we're going to plug in, well, x is 2, so we have 2 is greater than or equal to negative 1. That is true, right? Then we have y, we're going to plug in 7 is greater than 2 times 2 plus 2. So we have 7 is greater than, we have 2 times 2 is 4 plus 2, and 7 is greater than 6. Is 7 greater than 6? This one's true. This one's also true, so this is going to be solution. All right, last 2 examples, word problems. Let's end strong here. All right, the school that Jacob goes to is selling tickets to a concert. On the first day of ticket sales, the school sold 8 adult tickets and 8 student tickets for a total of $176. On the second day, the school sold 7 adult tickets and 8 student tickets and collected $162. Find the price of each type of ticket. All right, so we're looking for, so we're going to label our x and y. X equals going to be, we're just going to call that adult ticket. Cost of adult ticket. And then y is going to be cost of the student ticket. And then what 2 equations do we have here? Well, we're talking about we have day 1 and day 2. So we're going to have one equation day 1 and one equation day 2. So let's make an equation now. So we're going to do first day we had 8 adult tickets. So 8 tickets times the cost of each adult ticket plus 8 student tickets. So 8 student tickets times the cost of each student ticket equals 176. And then for the other one we had 7 times the adults plus 8 times the student tickets is going to equal 162. And we need to solve this. So we need to, what I'd probably do, this is probably an easier one to simplify. I'm just going to multiply either top or bottom by -1 to change the signs, because we already have 8y and 8y. That's going to make it nice for us. So we got 8x right at the top equation the same. I might multiply the bottom one by -1. It's going to be -7x minus 8y equals -162. Add these. We're going to get, these are going to cancel. We're going to get x equals, what, 14? So $14 per adult. And then we got to solve for y. So I'm going to plug into either equation. Let's just plug into the bottom equation. So we have 7 times 14 plus 8y equals 162. 7 times 14 is 98. plus 8y equals 162. Subtract 98. 8y equals, what's that going to be, 64. Divide by 8. Y is going to equal $8 per student. All right. Last example. Now, this last example is going to be similar to it's going to be similar to the ones we did in the lesson that I taught, and we haven't talked about one similar to this for a while. So make sure you pay close attention and take good notes here. Okay. You want to burn 520 calories during 60 minutes of exercising. You burn 8 calories per minute biking and 10 calories per minute running. How long should you spend doing each activity? All right. So for this one, we're gonna do. We're gonna have, like I said, so we're gonna have x equals biking time. Your x and y always equals what you're looking for, right? So we have biking time is what we're looking for, and y is going to equal running time. And then our two equations, we're going to have, one is going to be quantity and one's going to be value, okay? So one equation quantity and one equation value. That's kind of what we got away from for a while for the last problems we were doing here, okay? So one is going to measure how many, how many minutes we exercise, and the other equation is going to measure like how many calories we burn, basically, okay? So this one's going to be time, and this one's going to be calories, okay? That's what I mean by quantity and value, all right? So let's go ahead and figure this out. So if we have x is biking time and y is running time, and we exercise for a total of 60 minutes, what's the first equation going to be? Well, if I have x is biking time, and I'm doing a total of 60, I'm going to add y equals 60. That's our quantity or our time equation. And that's the easier one to kind of figure out. The second one's not too bad either, but it's going to be like your calories, all right? So we burn 8 calories per minute and 10 calories per minute running. So I'm going to write 8 calories times the number of times minutes I bike, plus 10 calories times the number of minutes that I run is going to equal the 520 calories total. Okay? All right, so now we just got to solve this. So I would go back and also review the lesson for this too, to kind of review some of the quantity and value problems because we kind of got away from that for the, like I said, in the lesson we did, or the homework we did. Okay, I want to cancel the x's. I want to do elimination here. What can I multiply the top by to cancel the x's? What's the opposite of 8x? It's negative 8x. I'm going to multiply the top by negative 8. So we're going to get negative 8x minus 8y equals negative 240. Or no, negative 480, sorry. And that's how I was checking myself. 8x plus 10y equals 520. Add straight down. X's are going to cancel. 2y is going to equal 40. Yep. Divided by 2. Y is going to equal 20 minutes running. Now we got to find x. So it was x plus y equals 60, and if y equals 20, so we got x plus 20 equals 60, subtract 20. Y is going to equal 40, x, sorry. 40 minutes biking. All right. We cover everything? I think we did. All right. Thank you for watching. Have a great day. We will see you soon. Study for your quiz.